Hello friends, welcome to this video about range of representation and rules for sign extension. The objective of this video is to explain the concepts of range of representation and the rules for sign extension of binary numbers. A good understanding of these concepts is important before going into the methodology of binary numbers, sign multiplication and division. The difference between sign and unsigned numbers is that signed numbers can be positive as well as negative. In signed numbers, the most significant bit is dedicated to indicate if the number is positive or negative, 0 if it is positive and 1 if it is negative. Example, using signed numbers representation, 0101 is a positive number, which is equivalent to +5 in decimal, and 1101 is a negative number, which is equivalent to -3 in decimal. As a consequence of this most significant bit dedication, we lose in the range of positive numbers that can be represented, but we gain in the fact that now the computer can also handle negative numbers. So let's go first to the range of representation. The range of representation is the set of values that can be represented using a specific number of bits. For unsigned numbers, the range is from 0 to 2 to the power n minus 1. And for signed numbers, the range is from -2 to the power n minus 1 to +2 to the power n minus 1 minus 1. So note that the range is not the same if we are using unsigned numbers or signed numbers. Example, for n equal to 4, that means using 4 bits. For unsigned numbers, the range of binary numbers that can be represented is from 0000 to 1111, that means from 0 to 15. Because the smallest number, which is 0000, is 0 in decimal, and the highest number, which is 1111, is 15 in decimal. So the range is 0 to 15 inclusive. Let's see now what happens for signed numbers. We have to distinguish two parts, positive range and negative range. The positive range is from 0000 to 0111, that means from +0 to +7. And the negative range is from 1000 to 1111, that means from -8 to -1, because 1000 converted into decimal is -8, and 1111 into decimal is -1. So altogether the range is from the lowest -8 to the highest +7. So in this case, the magnitude of the highest possible number is about half of the unsigned number. Because with unsigned numbers we can reach 15, but with signed numbers the highest we can reach is +7. As a consequence, using signed numbers with the signed bit, we lose in the range of positive numbers that can be represented, but we gain in the fact that now the computer can also handle negative numbers. Let's see now The rule for sign extension. As we explained in the previous video, in a system of n bits, the number of bits you may require to represent the result of a multiplication is 2 times n. Example, if you are using 5 bits, the product result of two numbers of 5 bits will need 10 bits. So, when we are multiplying signed binary numbers, we may need to perform what is called the sign extension. Or, in other words, we need to extend the sign bit of the partial products after each multiplication in order that the number of bits match. Sign extension means repeating the sign bit of the number several times in front of the sign number. The rule for the sign extension is: if the number is positive, you fill the front of the number with as many zeros you want. And if the number is negative, you fill the front of the number with as many ones as you want. Any sign number can be sign extended to any number of bits. And with the sign extension, the value of the number remains the same. Example, here +7, which is 0111, has been sign extended to the 8-bit form. For this, we have added 4 zeros in front. And here, -5, which is 1011, has been sign extended to the 8-bit form. For this, we have added 4 ones in front. This is the verification that the value of the numbers remains the same, +7 and -5. When you do this calculation, remember always that the front one is associated to the negative sign. In this case, the front one is located in column 7, so its value is -1 times 2 to the power 7. That means equal to -128. In summary, the range of representation is not the same if we are using unsigned numbers or signed numbers. Using signed numbers with a signed bit, we lose in the range of positive numbers that can be represented, but we gain in the fact that now the computer can also handle negative numbers. Any signed number can be sign extended to any number of bits. And remember, with the sign extension, the value of the number remains the same. That's all for today. Thank you very much for your attention. Have a nice day. If you like this video, please hit the like button and subscribe for more videos.